I want to address the spring tension in the joystick of my Zytec X52 HOTAS. I was planning to use a bit of aluminum to compress the spring a bit more, but I found a suitable piece of stainless steel in my parts drawer, so I'm gonna use that. I drilled the hole to 12.5 millimeters. As part of my plan for customizing controls for Star Citizen, I also want to do something with my HOTAS system. I've got an X52 system by Zytec. It's a very popular one, although this is a bit older model. It's the non-pro version. And one of the flaws of this one is that the spring tension isn't very high. As you can see, the stick is a bit floppy, and there is a way to improve this, and that is by compressing the spring a bit more. And there are numerous ways to do this. There are a few simple tips you can find on YouTube. I will put a link in the description. But I'm gonna make a spacer which I can fit on this on the shaft around here. But first I'm gonna open up the joystick. I already did one of the available mods. Maybe you can see here. This is called a magnet mod. It improves the dead zones and reduces the jitter from the joystick. Now, one of the reasons why I opened this up was because I wanted to know if I could just unplug the stick and remove it. But it doesn't look like the cable is gonna fit through this hole, so I've got to try and open it up on this side. Also, it's maybe useful as a reference to get everything in view, so I won't have to open it up every time I want to check something. Here is the PCB for the toggle switches. This connector might be a bit dodgy. I've got a problem with disconnects. And then the stick loses power for a second, and then when the power comes back up, it recalibrates in the position. So if I've got it like this, then it recalibrates in this direction, which is unfortunate. Then I have to unplug the cable again, release the stick, and plug the cable back in to get a good calibration. Let's see this. Thought I had the right size, but I haven't. I'll be back. Right, I've got one which fits now. Also, there's Something else I might want to improve, there's this screw, which I can't unscrew completely. There's a little plastic part behind it, and you can put it in any of these slots, but you can't put it in between, and my hand, I think it's better to have it just in between, so I might want to adjust this part too. But for now I have to unscrew it. I wasn't planning on doing that today, but you never know. Don't know if I opened this part up in the past. There's 3 screws underneath the handrest. They're tiny Phillips heads. Okay, I've got a screwdriver which will fit. This disconnects the pinky switch. Right. So here is the screw I talked about. You can see how it can index, but somehow it won't unscrew completely. So that needs to be fixed or modded, whatever you want. This is a metal plate, and I think it's wedged in there. Can't really see what I'm doing at the moment. Maybe if I tighten this, I can push it out. This of course doesn't work when it's still on the stick, because you don't have the space for this. Here's the switch for the lock of the rotation of the Z-axis. And let's see. Just didn't mean to do that, but just one screw to hold the base together. And this is one of the most cheapest switches you can find. Switches which are used on almost everything. Like these buttons. It's even the same size. So I've got some spares in case this one breaks. Yeah. Where I can't just disconnect this. The wires are glued to the circuit board. Not entirely sure what I'm unscrewing, but right. Ooh. There goes a spring. There's another one. Right. This is what I was hoping for. Metal shaft is fitted to the plastic with a press pin. Here's the pin. think the cables are protected against the continued rotation by a piece of tape, which isn't real protection, of course. Let's see, there's two separate switches here. Which are also quite common, so you can replace them if you want. The spring for the trigger is close to the circuit board, or maybe it was hooked somewhere on this part. Yeah, it might have been hooked behind this spot. There's a little mark on the plastic, and this doesn't seem like a very good design. If it was resting against this piece of plastic. Spring. There's quite a lot of wires in here, more than I would expect. There's a circuit board over here, which has contacts for these buttons. There's another PCB in here. Or 8 even. There's also something I'm considering, that's changing out the LEDs for multicolored LEDs. So I can, this mode switch changes its color depending on its setting, but all the LEDs are blue. And, would be nice if this would change all the LEDs of the stick. That would really involve making my own hardware for this, my own controller. Also, I'm not quite happy with the dimming of the LEDs. Sometimes I can see them blink or switch on and off a bit. And maybe it's also a driver issue, because the dimming of the LEDs is controlled in the drivers. And I would rather just have a button on the device to adjust that. 4 more screws, and they hold the top plate. I don't know if I had to undo the screws. Yeah, I think so, because there are 4 screws here. Now I wonder if it's even possible to disassemble this. I don't think this connector will go through. What would it be a problem? Now the easy way to make a spacer is to make a disc with an open side, so you can slip it over the shaft without disassembling the stick. I know that's an option, but I just wanted to see if it was possible to disassemble the stick. the sides with the bronze bushing, I think. I hope it's bronze instead of brass. At least for metal, that would be preferable, but this is plastic. So to be honest, I don't know. Screws sticking to the magnets next to the Hall sensors. Yeah, I'm worried about breaking some wires. There's a connector for the pinky switch. I can't remember which screw goes where. I need calipers. So if I make a ring, then the bore should at least be 11.8 millimeters. And if I decide to make it slotted, then slot should be at least 8.4 millimeters. And that would leave me enough space to slip it over and compress the spring. Now this opening is a bit more shallow than I expected. It's 3.4 millimeters. I was thinking about making just a disc a few millimeters, but if I do that, then the spring isn't contained anymore, so I also need something to hold the spring in place. So I have to rethink my design, and to be honest, I'm also already working on a little disc, but the piece isn't piece of round stock isn't big enough to make a new white spacer. It's barely the size of the spring, which is 2.91 millimeters. And the disc I'm working on is I'm sorry, 29 point. It's a bit less. 29.1 millimeters, this spring. And the base, I hope this 33.3 millimeters. But I don't know if these parts together are that wide. Maybe a bit less. And they don't have to be a perfect circle. And now I've got 32.4. $32.5 or 32.7. So I didn't measure this right first time. I don't know what I did wrong then. 32.7. Oh, I hope this was on camera. I can't see the display normally. Got to fold it up. Alright. Maybe it's also possible to replace this potentiometer for a Hall effect sensor and then put a magnet in. also considering adding more buttons. So it's good to see where there's extra space. This side, for example, but that's where my hand goes, so that's not a good spot. Okay, I will leave it like this for a while. Just don't touch it, and continue with the spacer I was going to make, or a new one. So this was the piece I was working on. It was kind of this way when I found it, somewhere in a drawer. It was 30 millimeters diameter. I turned this down to 29 point something. And it does fit the bottom of the stick. And the spring will sit on this ledge here. But I was expecting this to be this part to be much deeper, so I could make a disc of 3 or 4 millimeters and then just put it in here. But if I do that now, then the spring might be forced off the disc, because it isn't retained in the plastic part. So now I need to make a bigger disc, which can also hold the spring on the outside. I did some reassembling, and that's because there's one more important dimension, and that is the spring travel. Now there's quite a lot of travel, but if the stick is moved forward or to the other side, then the spring is compressed and the travel gets less. And if I take away too much travel, then the stick won't be able to achieve its full movement. So that's something to watch out for. I'm thinking about the part I'm going to make. I was thinking about this kind of ring, which fits in here and then just compresses the spring and also keeps it in place because it's fitting it inside another cylinder. The other option is making a ring fit on the outside of the stick. And if I do that, I can possibly fit other stuff to the ring. And that's nice if I want to modify it. Modify the joystick further than what I'm currently doing. Back to the aluminum. I cleaned one end of the part, and now I'm dialing it in, and I will make the ring. Bored the center up to 20 millimeters. Finish boring one side. This part really has to fit, and I think it does. There is a little edge somewhere. I can even make it a bit deeper. I think I'll do that. There's about 1.5 millimeters to go. It's the next day. I tried parting off the piece yesterday, but it was making too much noise. So I did it today at work at a slightly bigger machine. But there's not very good tools over there. The parting tools, I mean. And I'm gonna reverse the piece and clock it in the forge jaw.